the margin of error for a 90% confidence interval when the standard deviation is 50 and n is 25. So that means we need to find that Z number.
Mm-hmm.
So you put that, the 90 in the applet at the top. Well, we already know what it is.
Yeah, so we just have that little, when you, when you know what that little A upside down A thing and what U is, then you can just put it into the equation, right?
Yep. So we know that the Z is 1.645.
Mm-hmm. Well, wait, hold on.
For 90%?
Yes, you were totally right.
And then times, and then times the standard deviation, which is 50, divided by the square root of 25, which is not square rooted, but.
Okay, so
Do you have? Alexis, can you hear us? Is she still frozen?
Yeah, I think she's still frozen. And it. Sorry, I'm just trying to write all this junk down.
Sorry, I had to turn my light on.
No, you're fine.
It was too dim in here. Okay. So the Z number is, the critical number is.
All right, so the equation that we use, that's where I'm getting confused. Oh, you're working, Alexis, yay.
Oh, good. It kept going out on me for some reason.
Yeah, you froze, but you're good now.
Yay.
Okay, so we're just right on number 3, so we're just starting.
Oh, perfect. I'm going to log in right now, but you guys can keep going.
Sorry, I didn't have my phone, I wasn't on Wi-Fi. Okay, so do you see where the equation is parentheses and then Z times the standard deviation divided by the square root of n?
All right, I got that super long equation where it was like x minus z. What's the comma? Is that times?
No, that is where you find, so you plus or minus by.
Am I just looking at the wrong thing completely?
You find the margin of error. To find the margin of error, then you okay. I don't know if you can see my little notes here, but to find the margin of error for a 90%,
yeah,
you put the 1.645.
Okay.
Okay. Times the standard deviation, which is 0.5, no, which is 50, divided by the square root of 25.
So times 1.645 times
the standard deviation,
which is 50, right?
50, divided by the square root of 25.
That's it. That's the equation.
Well, that's the beginning. That's the first part.
Okay. Let me see this.
So how could I forget this already? And I took such good notes. Okay. Okay.
So
With that equation, I got 16.45.
oh, sorry. I found it. Okay. So
Did you get 16.45?
yes, because 50 divided by 5 is 10 times 16.45. Yes.
Okay, so 16.45, and then you plus 1.96. Oops, that's my mistake. 16.45 plus what was our z plus 1645 plus 1.645 times standard deviation divided by the square root of 25. I think it's 32.9.
All right. What was that second equation?
Okay, so I wish I could show you. Okay, see where we're using the, okay, we're using 90%, right? Which is
Yeah.
1.645. Okay, so to get the confidence level, we take 1.645 times 50 divided by the square root of 25, and we got 16.45, correct?
Yeah.
Okay, so then I think you take, you know what? That doesn't sound right. Hang on just a second. I don't know how I got this one right here. I think it's just, I think that the first one is just
16.45.
16.45 because it's not asking what the mean is. But it does say the margin of error. Okay, so that would be the margin of error.
Okay.
I believe. Okay, which of the following statements is true? Standard or deviation squared is the interval estimate of x bar. X bar is a point estimator for mu. Let's see. Okay, I think I. Okay, so I think that x bar is a point estimator for mu, I think. Or it could be the other way around. Oh my gosh. I thought I was so confident in this yesterday. I thought, oh, I understand this.
Yeah, in the textbook, I see X from U and then U from X.
So x bar is a point estimator of mu?
Well, I'm seeing it both ways. That's what I can't figure out.
Well, the good thing is with these like multiple choice, we have 3 opportunities to be able to find the right answer.
Yeah, I think it's
Should X to U?
I think x bar is a point estimator for mu.
Yeah.
I think. Ugh. I don't know.
Guys, I'm gonna fail this class. I'm so scared.
Don't we have to get a C in it?
Yeah, to pass.
Yeah. I don't know. Okay, Gina wants to construct a 95% confidence interval for GMAT scores. She knows that the standard deviation is 113. She collects a simple random sample of n equals 64 and computes x bar equals 526. Okay. What is the point estimate? I think, let's see. Okay, this says X bar is the sample mean or the point estimator, and standard deviation is the X bar is the sample mean is the point estimator. So I think X bar is a point estimator from you, I think. Okay, and then on the next one, the sample population standard. 0.68. She went to collect a sample size. Okay, so on number 5, I think we go, so the Z number, critical number for 95% is 1.96, right? Times the standard deviation is 113 over the square root of 64. But where does how does the X bar come in?
So is it X bar minus 1.960, the standard deviation divided by n?
Square root of 64. Okay, I think the point estimator for the GMAT score is 526. Because when I look
X.
So X bar is the sample mean or the point estimator.
That makes sense.
What is a margin of error for the 95% interval? Okay.
This is where we would do that calculation, right?
What's that? So for number 6, yeah, we would do that calculation. 1.96 times. What?
113 over square root of 64.
Yeah. $27.686. What I can't figure out is where did they get the 3, 2? Oh, yes, I do know. I do remember. Okay. So have you guys gotten an answer for 5 or 6 yet? Well, 5, I think the X bar is the point estimator, which is 526, I think.
Yeah, and for 6,
I got a high number.
High number like what?
Like 32.585.
I got 27.685.
That's what I got.
That probably.
Because I think what we were doing wrong before was we were just putting it all in the calculator. I've been doing things individually from now on.
Oh, see, I didn't do that. I forgot. Okay.
Yeah, so I always do the 113 over the square root of 64 first, square root it, then I do the division, and then I times it by the first.
Okay.
Do you think that what we got was right, Lori?
Yeah, but if it's 27,685, do we round it up to 686 or no?
No, I think it's rounded to 3. Let's see.
Okay, just a 3.
Yeah, round decimal to 3 places.
Okay, and then we use that point estimator, which is
526.
526, and then we plus it.
What is the lower limit? Do we minus it?
Well, yeah, you minus it for the lower limit, and then you plus it for the higher level.
So it would be. So we would
526 minus 27.685.
So
498,315.
you got 498.315, right?
Yeah.
Okay.
Hang on, I'm gonna do this again really quickly just to.
Stand it. Hey. No. Hey. Sorry. Oh my gosh.
That's a squeaky toy, right? Uh-oh. Okay. I'm gonna try this again. Did we subtract that? Okay, 526 minus
27.685 equals.
times 1.645.
Oh, I need to do up. 526 plus 27.
Times 113 divided by the square root of 64.
Yeah.
Wait a minute. That doesn't sound right. Stop it, Snooks. Stop. Wait a minute. Are we doing 95%? That's why I'm doing it wrong. Sorry. So it's
1.96.
1.965.
Just 96, I think.
Just 96. Okay.
1.96, yeah.
So we go 526 minus that times, and what's our standard deviation?
Oh, you have to times it by the standard deviation?
I got the same thing as you did the first time.
So when we're trying to find the lower limit of confidence level, we just take 526 minus that 27.685?
That's what yeah, I think so.
Okay. Because I just.
But I'm double checking. I'm doing the long math on it just to make sure.
Yeah.
Yep, 498,315.
Okay. And then for 8, I got 553.685.
Okay, hang on, I haven't done it yet. 4
Plus it, right?
315. Yeah, and then you plus it. So 526 plus what? Plus
27.685.
553.685.
27.685. Right?
What'd you get?
The 27.685. So I got 553.685. Yeah.
Yeah, that's what I got.
Perfect.
Okay. 9. What would happen in the width of the confidence interval if Gina's increase the sample size?
With the confidence. Oh,
What would the width of the confidence interval, what would happen to the width if the confidence interval increased, if Gina increased the sample size? As the sample size increases,
Maybe decrease?
it would decrease, yes.
wait, would the confidence level decrease because the confidence level would go up if they had a higher
Here's
sample?
what I wrote in my notes. It says, as the confidence level increases, the width of the confidence level increases.
What about
Okay,
the
and it says,
sample size, though?
it says as the sample size increases, the width decreases.
Oh, okay.
So she's increasing the sample size so it would decrease.
Gotcha.
What would happen to the width of the confidence level? Gina changed it to 99%. So if the confidence interval increases, then the width also increases.
Increases.
That makes sense.
Okay, hang on. I gotta let my dog out. Sorry. Come on, Snooks. Let's go potty. Come on. Let's go. Potty. Keep going. I'll be right back. Sorry.
Puppy break.
Oh.
Ah, fun. It's homework time. This is great. What did you do? What did you do? Okay. Hi. Oh. Hello.
All right.
Nike. Don't know.
Come here.
No, no.
Come here. Okay. We're on 11.
Mm-hmm.
Bright Bulb Light Bulb Company is planning to study and to assess the average life expectancy of their light bulbs. They know the standard deviation is 400. They want to have a 95% confidence level if the margin of error is 50 hours. What sample size do they need?
Is this the one where we would use the probability applet?
I think so. It might be also the one where we square it.
Hey.
Okay, do we have a standard deviation? Yes. We want to create a confidence interval. Okay. So I think we need to get the that Z number.
Mm-hmm.
So we need to put in the applet 95 we need to do 95%, which is
I got a Z-score of
1.960.
1.96. Okay. 1.960.
Is that is it? I don't know.
That's the confidence number, or what do they call that?
Oh, we have to put, that's what this is. So, Alexis, I think you were right.
let me put it in again.
Wait, did you get 1.960? Because I just went and shaded that middle part and then put in 0.95 and got 1.960.
Well, we know by this little.
Yes, that's what I got.
Yeah.
We know that little box.
Yeah.
It's going to be 1.960, but then so I think we want to do this. I think we want to do this equation, which is N equals Z times A over M. squared. So,
And squared?
yeah.
Okay.
Do we know what the mean is? Is it 500? No, I mean 50.
That's the margin of error.
Okay.
So I think we're trying to find.
Okay, here, let me read this to you. I think I got it. So we're doing a equation where with a specified margin of error, M, so the margin of error is 50, is given. So it's N equals the z-score, which is 1.960 times the standard deviation, which is 400, divided by the mean, or the M margin, which is 50, and you square that. So here's the equation.
So you square the answer of 784 divided by 50.
I think this is what we need. Like, can you see that?
Oh, okay, perfect.
I think that's what we need, because we're trying to find N. Okay, we're trying to find the sample size. So I think that is 1.96 times 400. Whoops, oh shoot, I just got out of it. 1.96 times 400, and then divided by 50, and then you square it. I think the answer is 2545.86, and then it says you always round up. Let's see, example, if you get a 1.120, you round to 102. So you round to the nearest whole number. So in this case, it would be 246. Okay, let me try that again. Are you guys trying that on your calculators?
Mm-hmm.
1.96 times 400.
I got 0.3136.
You got what? What did you get?
So it was N equals 1.960 times 400 divided by 50 squared.
50 squared. I mean 50, and then you square that, and then you square that whole answer.
That's the issue. There we go. That's why I got it wrong.
Do you guys have a statistic or whatever these are called, this kind of calculator?
I'm doing it on the computer.
Okay, same thing. What do you have, Alexis?
Well, I just got 3.959. I did something wrong.
Okay, so Alexis, do 1.96 times 400.
96 times
1.96 times 400.
and then divide by 50, right?
And then divide it by 50, and what do you get?
I got 15.68.
Yeah, and then you square that.
Which I did that. 15.68. 15.68.
So what did you get, Lori?
I still got 3.959.
I got
okay when you
5.86 to 24.
That's what I got. 245.86.4, and you round it to the nearest whole number, so it's 246. Okay, Alexis, I think what you're doing is, okay, when you got that answer of 15 point what?
68?
I think it was 86.
Oh, yeah.
86. Okay, so then you times that by another 15.86 because that would be square rooting it. Oh, wait a minute. I'm wrong. Hang on just a second.
Wait, do we square root it or are we
Squaring it. You square it.
okay.
Okay, you're right. It's 15.68. Sorry, Alexis.
Oh, okay.
So
It is
15.68.
15.68?
Pardon? So you take 50, so you get so 1.96 times 400 divided by 50.
So do you do 400 divided by 50 first and then times it by, so that would be 8 times 1.96, oops, 6 equals 15.68.
And then you have to square that. So you basically you times it again by itself.
Yeah, I still got 245.8624.
Right.
Okay, that's what I got now.
Okay.
Okay.
Okay, and it says that you round it to the nearest whole number, so that would be 246.
Okay.
Well, that may not be right, but I think that it is. Okay, if the mean salary of actuaries is the mean of 100,000 and standard deviation is 36,730, you are interested to know if the mean salary for women actuaries is different from the population mean, but you are not sure if it is higher or lower. You set up a hypothesis test with a level of significance of A equals 0.05. Okay, so you collect a random sample of N equals 36 women's salaries and find that X bar is 111,000. So I think we go back to that.
To the applet.
I don't think you have to do the applet this time. I
Oh, we
think
don't?
Yeah, because it's 95%. I think we just find, we do that little equation and then we minus it because it's finding the lower limit.
where do you see? Oh, yeah, because it's
Yeah.
5%, so it'd be 95%.
Yeah,
Okay.
so does that make sense? We just have to do that little equation again and then minus it.
Yeah.
Right?
Okay. Mm-hmm.
Well, you plus or minus it, right? Because you want to.
Well, this one's lower limit, so minus.
Okay. Oh, lower limit. Okay. Okay. So it'd be 95% is 1.96 times the standard deviation, which is 36,730 divided by the square root of 36.
So 6.
Oh, I got a high number.
Well, we want a high number because we're talking about large numbers like salaries.
So I got 11998.4667.
That's what I got.
Okay.
So 11998.467. Okay, but we want to find the lower limit, right? So we take 11998.47, maybe,
Mm-hmm.
and then we minus.
So
No, that's not true. The X is 111,000.
yeah, so it would be X minus, so it would be 111,000 minus 11,000, yes.
998. Point. Right.
minus 998.41
99.0154.
4 5s. All right. I got 99,001 point. I guess we're
That's
going
what I got.
to.
Okay, so it says to round to the nearest whole number. So
Good.
that would be
2.
2.
99
002.
1 2. No, it's 2. 002.
Yeah. Okay. What is the upper limit? So you take 111,000 plus 1199846. Which is
122 998.
Yeah, but it says to round to the nearest whole number, so I guess that would be
8.
8. Okay. 112. Whoops. 122 998.
Guys, at this point, I always just get really scared that we had absolutely no idea what we're doing and we're going to get all those math problems wrong.
I know.
And that could be, but we'll wait and see. There
We're
are
gonna
3
feel it.
requirements that be checked when computing a confidence. Oh, okay, I wrote this down. Here we go. I actually wrote it down. There's
Woo.
3 requirements for confidence intervals. For one sample, they are, the first one is sample is simple random sample
Okay.
drawn from the population. And the second one is population of the standard deviation is known.
No.
So, and that it's normally distributed, so it's all of the above.
All the above.
Okay, I'll go ahead and submit mine. Okay.
Okay.
My heart always pounds a little bit. Oh. Huh. We got 2 half points.
Uh-oh.
We got 4 half points.
What?
No, wait. They're only worth half a point. Oh my gosh. Hang on, let me go to the bottom. We got 100%.
No way.
What?
We got 100%.
No.
True, true.
Wow.
So did you guys submit? Did you get 100%?
Yeah.
I think I put number 13 in wrong.
No.
13?
Yeah. What one was 13?
122,998.
I put 172. Okay, yeah, we're good then.
Yay.
Sweet.
We did it.
That was even less than an hour.
Wow, guys, that's a record for us.
And we didn't have to look at anybody else's video either.
That's an accomplishment right there, too.
Listen, I am telling you guys, if you do anything, watch the videos. Yeah, because they were so helpful. And I took really good notes on the videos, on the explanation videos. They were so helpful. I tried looking at the textbook. It was just mumble jumble to me.
Yeah, the textbook is always super weird just because it's like, let's talk about baseball and focus on the story. We're like,
yeah, they're like, and sometimes I'm reading and it says the mean of the sample population of the mean of the entire population. I'm like, what does that even mean? I don't understand it.
what does that mean? The mean of the mean of the mean mean?
Yeah, right. So those little videos they put on there under the preparation materials are super helpful.
I will definitely start doing those at the beginning for sure, though.
Yeah, super helpful.
Guys, so proud of us.
Sweet.
All right, well, I will turn this in for us.
Thanks for doing that, Cassie.
Oh, it's no problem.
Okay, so Wednesday, same time?
Yep.
Yeah.
Are you guys doing that session where she tells you what you got wrong?
I haven't decided yet.
Me neither.
Well, mine is tonight. Aren't they all today? I don't know. I can't remember.
We kind of gave up a little bit, which is bad.
I think that I'm going to go ahead and do my homework right now because why
Everything's fresh. No, seriously, like that helps so much.
yeah, why I'm remembering some of this. All right.
Sweet. Well, good luck with your quizzes this week, guys.
Thanks. Bye.
Here.
Wednesday.
Bye.